Welcome to Programming for Mechanical Engineering, EML 2032. Today, we'll dive deep into some core programming concepts in Python. We'll cover 5 main topics: list variables, list definitions, list slicing, list mutability, and matrices as 2D lists. Lists in Python are versatile. They allow us to store multiple items in a single variable. Lists are just one of the 4 built-in data types in Python meant for storing collections. We also have tuples, sets, and dictionaries. List items are indexed, starting from 0. This means the first item in a list has an index of 0, the second has an index of 1, and so on. Lists in Python are mutable. This means we can change, add, or remove items after the list's creation. For example, in this aluminum list, you can see various attributes like atomic number and state. We can modify any of these attributes as needed. Here's an example of list mutability. We're changing an item in our aluminum list. After the change, you can observe how the list gets updated. Challenge time. Can you guess the output of this code? Remember, understanding the behavior of lists and their indices is key. Now, let's dive into 2D lists, or as they are commonly known, matrices. Python provides several ways to work with 2D lists. Here's an example using our familiar aluminum list. Another challenge for you: using this basket list, can you access and print the item oranges? Welcome back to Programming for Mechanical Engineering. Today, we'll explore the differences between Python methods and functions and delve into list methods. Our main focus today will be on understanding the distinction between Python methods and functions, and then exploring various methods specific to lists. Let's start by distinguishing functions from methods in Python. At their core, both have a singular goal: to perform operations. However, a function is a series of steps executed as one unit, encapsulated under a name. An example of a built-in function is print. Functions can be broadly categorized into built-in functions, like print, and user-defined functions that you can create. User-defined functions allow for customization. For instance, consider the add function we defined. It takes 2 parameters and returns their sum. Using this function, adding 10 and 30 would yield 40. On the other hand, methods are tied to objects in object-oriented programming. They access and potentially modify the data within these objects. Essentially, while a method resembles a function, it's associated with an object and operates on the data inside that object. An example of a method's syntax is object, name of method, input. Python provides a plethora of built-in methods tailored for lists. Some of these include append, which adds an element to the end of a list; clear, which removes all elements from a list; copy, which returns a copy of the list; and many more. You can find detailed descriptions of these methods on platforms like W3 Schools. That concludes today's session on Python methods and functions. Practice these concepts, explore the list methods, and we'll see you in the next class.